So in order to calculate the pH and in order to understand the buffer action, let us have some practical examples. So for example, as we have discussed already in the case of acetic acid and the sodium acetate, that is the acetic buffer. So in that case, we let us have some derivations in order to understand that how buffer action works. For that purpose, we will write a balanced chemical equation, that is acetic acid, and when it is dissolved in water, it gives us the acetate ions, that are CH3COO negative plus hydronium ions. So as let's say that we started the reaction from the concentration of 1 molar of acetic acid. So when the 1 molar of acetic acid is dissolved in water, it ionizes and gives us 1 molar of acetate ions and 1 molar of hydronium ions. And as this is a reversible reaction and it will reach the equilibrium, so at the equilibrium state we can find the value of Ka for the acid, that how these acids, what is the dissociation constant for the acid. So in order to find the dissociation constant for the acid, we can write the equation, that is the molar concentration of the products to the molar concentration of the acid. So here are the ions that are acetate ions, molar concentration, product with the molar concentration of hydronium ions over the molar concentration of acetic acid. By putting the values of these substances, we have noticed that the dissociation constant for acetic acid becomes 1.8 into 10 raised to power minus 5. This is the dissociation constant value for the acetic acid. So after that, in order to find the pH of the solution, first we have to identify and we have to find the value of hydrogen ions. In order to calculate the value of hydrogen ions, let us have the equation that rearrange. So upon rearranging, equation, we have the hydronium ions. Hydronium ions will become equals to the dissociation constant of the acid multiplied by the concentration of the acetic acid over the concentration of acetate ions. And as we know that the concentration of acetic acid and acetate ions are 1 molar, so by putting the value of 1 over 1 and putting the value of dissociation constant, that is the value of dissociation constant of the acetic acid is 1.8 into 10 raised to power minus 5 multiplied by 1.00 mole over 1.00 molar. Here we can notice that the value will remain same, that is 1.8 into 10 raised to power minus 5. This is the concentration of H plus ions. Now in order to find the value of pH, let's have a negative log on the both sides of the equation. Negative log of the concentration of hydrogen ion will becomes equals to negative log of the 1.8 into 10 raised to power minus 5, and this value will comes 4.74, as this is the pH and this is known, will become 4.74. This is the pH value of our standard buffer solution before adding or introducing any strong acid or base into the solution. Let me clear the board and then we will write something more on the board. So as we discussed that the pH of the solution becomes 4.74, and this is the pH of our standard buffer solution. Now if we add some acid to the solution, that is if we add an acid, that is HCl or something else, to the solution. So as we know that the standard equation for the whole buffer solution is acetic acid, and it dissolves and gives us acetate ions and hydrogen ions. So here, by the introduction of any acid to this, as this is acid HCl, so it will ionize in the form of H positive and Cl negative. In this case, we have an acidic part, that is hydrogen ion, that will affect upon the pH of any solution when it is introduced. So due to the presence of a buffer solution, so when this hydrogen ion comes in contact with this buffer solution, having the acetate ions of the salt, and that will react with the salt, and acetic acid will form again, and it will restore in the form of undissolved form of acetic acid. So the concentration of acetic acid will increase and the concentration of acetate ion will decrease in this case. So in order to introduce this and in order to find the value of pH after introduction of acetic acid, say we introduced is up to only 0.02% of HCl to the solution, it will affect upon the concentration, and the concentration of acetate ions will decrease due to the reaction of combination of this hydrogen ion with the acetate ion, and acetic acid will restore. So the concentration of acetic acid will increase and it will become, the concentration of acetic acid will become 1.02 and the concentration of acetate ion will become 0.98. Let us find the value of concentration of hydrogen ions once again. So here the concentration of hydrogen ions will become, from the formula, Ka into the concentration of, as we know that the concentration, we will again put here the concentrations and we will find the formula. So the acetic acid over acetate ions, it will gives us 1.8 into 10 raised to the power 5 multiplied by, here we will put this value, that is 1.02, and the ionic value will be 0.98. By solving these mathematical terms, the answer would be 4.71. Like the pH is decreased due to the introduction of hydrogen ion, but this is very less, and this is not the value of pH. For example, so the concentration of hydrogen ion becomes 1.7 into 10 raised to power minus 5. And now by taking the log on the both sides, log of hydrogen ions will gives us 1.7 log of into 10 raised to power minus 5. and the log of concentration of hydrogen ion is always known as the value of pH. So pH and log of this value will become 4.71. This is the pH of the buffer solution after the introduction of an acid, that is a strong acid, to the solution. And now we will add some base to the solution. So upon the adding of the base to the solution, we will have further so if we add a base to a buffer solution, it will ionize. Say this is sodium hydroxide of 0.02%. So 0.02% of sodium hydroxide, it will dissociate into ions of Na positive and hydroxide ions, OH negative. In this case, these hydroxide ions present in the solution, present in the base, will react with the hydrogen ions of the acid and they will form water. And water molecules, with the liberation of water molecules, the concentration of hydrogen ion will decrease in the buffer solution. So to maintain the concentration of hydrogen ion, from here the acid will again dissolve and it will ionizes in the solution, and it will complete the deficiency of this H plus ions that is come due to the introduction of hydroxide ion. So let us summarize it that due to the introduction of a base in the solution, the hydroxide ion will react with the hydrogen ions and the concentration of hydrogen ion will decrease and equilibrium will shift it towards the backward direction, and from there the acetic acid will again ionize into the solution to compensate and to balance the concentration of hydrogen ion to overcome the deficiency. So in this case, the concentration of acetic acid will decrease as it will ionizes further, and the concentration of acetate ions will increase. So due to the introduction of the base, the new concentrations would be the concentration of acetic acid, as we say that it will decrease. So due to the introduction of 0.02%, the new concentration value would become 0.98 mole, and the concentration of acetate ions will become 1.02. Now if we find the concentration of hydrogen ions present in the solution upon the introduction of a base to the solution, it will gives us the value, that is the concentration of hydrogen ion will be dissociation constant of the acid into molar concentration of acid in this case. Let us put the values in the formula multiplied by 0.98 over 1.02. So now as we can see that the concentration of acetic acid has been decreased and the concentration of acetate ions are increased, and after the introduction of the acid will be restored and the concentration will gives us the value of 1.9 into 10 raised to power minus 5, and this is the concentration of hydrogen ion. By taking negative log on both sides, negative log of concentration of hydrogen ion upon the negative log of the 1.9 into 10 raised to power minus 5, this will gives us pH, and that will comes 4.77. That is the clear difference between the pH values, but this is a very limited difference, and we can check it that the buffer solution has kept the pH value within a narrow range of limits. That is, upon the introduction of acid to the solution, the pH changes from 4.74 to 4.71, and upon the introduction of a base to the solution, the pH changes from 4.74 to 4.77. That is a very slight change as compared to the water. Let us discuss the case of pure water. If we have a look upon the pure water, so as we know that the pH of pure water is 7.0, and the experimentations confirm that when we add only 0.02% of a strong acid into the water, so the pH will changes from 7.0 to 1.7, and same is the case with the adding of the base. If we add 0.02 mole of a base, then the pH value will change from 7.0 to 12.4. This is the clear difference that before the adding of base or acid, the value of the pH of pure water is always remain at 7. But when we add only 0.02% of an acid, so the pH becomes 1.7. And if we add some amount of base to the water, that is only 0.02%, so the value becomes, the pH value changes from 7 to 12. That is a very huge and clear difference between these values of the pH. But in case of buffer solution, we have noticed that buffer solution maintains the pH within a narrow range of limit. Thank you.